In this scenario, we'll go back to our good friend Pete, who also, in addition to being a basketball fan, happens to be a weather buff. And he actually runs his own weather station at his house. It actually sits outside in his backyard and reads the weather information around him through a series of sensors and then transmits that back to Weather Underground, a popular weather internet service, and allows him to view the weather and statistics about it from the comfort of his office via a web browser. So what's happened today, however, is that Pete has woken up and he's going to look at the weather. He's going to learn a little bit about what's going on, what the forecast is, maybe how much rain there was last night. And he goes to look at it, and the screen doesn't look quite right. First of all, it's kind of grayed out. It's this gray color, and notice at the top how it says 9 hours since last update. And this system should be updating really every few seconds. It should be something that's happening all the time, and we shouldn't have a case where there are 9 hours since the last update. So something's clearly gone wrong here, and we've lost our connection to our weather service, or at least Weather Underground, the service it connects to, has lost that connection. So our goal here is really to investigate why that connection was lost and do a little bit of an investigation, kind of an Internet of Things type deal, since we have this sensor array that sits in our backyard, or in Pete's backyard, I should say, and has an IP address. So it's kind of an embedded device in that sense. So that's what we're going to do, is we're going to dig into this exercise by looking at the packets. To better understand this scenario, it's important to show the network diagram so you understand how all these different components link together and how the weather station is supposed to communicate. In this case, we have our weather station, which is what exists in Pete's backyard, and it connects via an RF link to a weather receiver that's in Pete's house connected to his network. That receiver has an IP address of 172.16.16.154, and it connects to Pete's router, which has an IP address of 172.16.16.1. The weather station communicates to the weather receiver, which then communicates through the router to the Wonderground server on the internet. And it's this Wonderground server that aggregates this information and makes it available via a web interface that Pete can view. Now, the weather receiver itself has its own interface, but in this case, Pete logged in, and it turns out that receiver, like many of these Internet of Things type devices, doesn't have really great logging and provides really, really cryptic error messages that are not super helpful. So nothing was to be gained from that, so we're going to have to look a little bit more in depth, which is why we're going to look at the packets. Now, for Pete's purposes, capturing packets, obviously we can't capture the packets of the weather station to the weather receiver, or we could, but that's a little bit beyond our scope here. In this case, we're actually going to connect and see if we can get the packets from the weather receiver going to the internet. So a couple different ways to do that. Maybe you have a tap and you can install a tap. ARP cache poisoning would also work here as well. But the important thing to know is the capture we're about to look at, which is called weatherbroken.pcapng, was taken inside Pete's network, looking at traffic going from the weather receiver out to the internet. So that's what we're going to look at here when we flip over to the packet capture. We're looking at the packets that were captured from Pete's system now, and we don't have a lot of packets to deal with like we did in some of the other examples. I've actually isolated this down, in this case, to just 9 packets, but it's important to know that what Pete observed was really this same exact stream of packets, more or less, occurring over and over again every few minutes. So what we see is what we got, and it's not a lot to work with, but that's probably actually going to make our analysis a bit easier. Instead of focus on statistics and comparing numbers and counts of things, we can actually dig into the specific entities involved in the packet capture and actually look at the contents of the capture as well. Now, you may be tempted to just go in and start following the TCP stream and seeing what's going on, and we'll get there, but I think it's important to understand, again, the lay of the land and what entities we're working with in this case. So here we have a couple of things going on. First, we have a source IP address of 172.16.16.154, which is our weather station receiver inside of Pete's network. It's attempting to make a TCP connection on port 80 to this device 38.102.136.125. And that's port 80, so we can assume that's probably HTTP type communication. And sure enough, if we look down here, we see that we have a GET request and an HTTP response. And kind of at face value, things look fine, right? We see a GET request, we see an HTTP response that is okay, so we don't see anything that immediately looks wrong. So let's try to understand what's going on here, and let's actually start maybe by understanding what IP address we're dealing with, this 38.102.136.125 address. What is that? What can we learn about that? Well, we can't learn a lot about it here necessarily, but we can learn a little bit by doing some open source intelligence research. And when I say open source intelligence, or OSINT, I'm talking about taking the IP address and searching for it on a couple of popular websites that can provide additional information about the IP address. So let's do that here, and I'm going to go ahead and open up Internet Explorer, and I have research.domaintools.com already pulled up, and we're actually going to go ahead and run a search for this IP address in this tool, which is going to do a whois lookup and tell us who the registered owner of it is. Now, of course, if I'm going to do this, I'm going to have to tell this that I am not a robot, or at least that I'm a very cleverly crafted robot that can identify images of buses. So I'm going to go ahead and do that. Looks like I validated that and hit OK. And we're going to get this response back. It's going to tell us a lot of interesting information about where this is registered. Now, first of all, we see the IP location is registered to United States San Francisco Weather Underground. So that makes sense. That's good. We see a mention of Weather Underground since that's who we're hoping to be able to communicate with. That's good. We see the ASN listed. I don't really know what Cogent is in this case. Maybe an ISP, Cogent Communications. And we see some additional IP address registration information. We don't see anything down here that mentions Weather Underground. We see PSINet, which we don't know what that is. Of course, we could Google it and maybe find out. And I think if you do Google that, you will see some references to Weather Underground as well, and the assets associated that are there. One other technique I like to use is to use passive total, and I'm here at passivetotal.org. You have to register for this service, but it is free. I'm logged in here, and I'm going to go ahead and run a search for this IP address, and it's going to do a lot of interesting things related to passive DNS. So looking at the history of what domains have resolved to this particular IP address, and this will tell us if Weather Underground domains have been known to resolve to this IP or in this range of IPs. Sure enough, if we scroll down here, we do see we have a couple of instances. It looks like we see rtupdate.wonderground.com, weatherstation.wonderground.com. These things make sense. We have a weather station, or Pete has a weather station in his backyard, and it should be communicating to wonderground.com, and it looks like this IP address is probably associated with wonderground.com. So that gives us enough to go on that to know we are probably communicating with an IP address that's at least in the right network, but we don't know if the problem at this point is on our end or on their end. Is our system not sending the right information? Is there something borked with the format of the information? Or is the server confused? Maybe it's not receiving the information correctly. Maybe something weird is going on there. So we're going to have to dig a little bit further into the traffic itself to figure that out. Now, we only have a single HTTP transaction here, which is going to make our analysis pretty easy. There's not a lot for us to look at. So we're going to have to hope the answer is here, because otherwise we don't have a lot to go on since we don't have any application logs. Now, we see we have a normal HTTP transaction set up. We have our TCP three-way handshake here, and then we have a GET request followed by an HTTP 200 OK. We don't see a lot of packets in between these two things, and that means that there's probably not a lot of data transferred, or at least less than the maximum segment size for a TCP segment here being transferred. So we just see a GET request and immediate OK. Let's look at the format of this GET request, because I think that's of interest here. It looks like we are making a GET request to the host of this IP address, this 38.102 address. We're using the user agent curl, so it's probably some simple scripted process going on. It's not like we have a web browser at play here. And then we have this interesting URI, and it's fairly long. You see I can scroll over quite a ways, and we see we have a few things going on. So let's look at that. We see the request is for /weatherstation, /updateweatherstation.php, ? And then we have all of these fields, and that's what we have here. So we have ID, which is a field, equals, and then a value. It looks like KGAO, so on and so forth. Then we have this field, password equals, and then a value, which is all zeros. We see temp F, another field, equals 43. Humidity equals 30. Do you see what's going on here? This is actually how the weather station is communicating its updates out to wonderground.com. It's how we're seeing this particular information. So we see a lot of interesting things we would expect to see from a weather station. We see humidity, we see dew point, wind chill, wind direction, wind speed, all the things that we saw on that screen earlier that said we were 9 hours out of date, all that information. we see it here. So the weather station is actually sending this information, right? We see all the updated information being sent. And Pete just took this packet capture, so you know it's recent. But there is maybe something that does look a little odd here. Now notice here we have our ID. And ID in this case is probably, maybe that's our username, right? We see KGAOKWO2. Now, if you remember, the location of Pete's weather station was in Oakwood, Georgia. So we see GA, Georgia, and then OAKWO. That's probably short for Oakwood. So this identifies maybe his weather station. Maybe that's his unique identifier. Followed by that, we see password. And password equals all zeros. Now, I want to give Pete a little credit. Pete works in tech, so I doubt he would actually set his password to all zeros. So that's of interest. Maybe that's not the correct password. Maybe something has gone wrong there. Now, we would hope in this case that we could go to our HTTP response and maybe see an error if that was the incorrect password. But we don't. We actually see HTTP 200 OK. However, let's dig into that. We have some data here. Oh, well, there you go. Look at this. I clicked on line-based text data in the packet details of this response. And it's a very short response, but it says invalid password. Password or key and or ID are incorrect. So it could be the ID is incorrect too, right? It's saying it's the invalid password for that specific ID. But one of those two things is wrong. So something's happened that has made that password or the ID associated be incorrect. And although this data is being sent up to the web server and it's responding HTTP 200 OK, it's not actually updating. The web application that is then receiving this data is responding and saying the authentication credentials are invalid, which is the source of our problem in this particular example. Now, I've gone ahead and switched over to a different packet capture, and this one's called weather_working.pcapng, and this is actually the same process, but one that is completing successfully, and it really validates our claim of what we think the issue may be, which is pretty clear once we found the appropriate context within the packet capture. In this case, Pete did find out, yes, his password is not actually 0000. He has a better password than that, so he went to the administration page of his weather station receiver, updated that, and then captured the packets after doing that. Now you can see here, if I click on this GET request, we still see, and you can see it right here at the top, KG Oakwood 2, so we still see the same ID, but now our password is different, and Pete is using the much stronger password of 123456778, which is much stronger than all zeros, of course, but still not totally great, but that's it. And the question is that working? We know that just by seeing an HTTP 200 OK, we don't know if that's enough because we saw that in the failed example too. But if I click on this and go down to the line-based text data here, we see we have a simple response of success. So we know that's working in this case. We can view that a little bit cleaner if we want to. We can follow the HTTP stream, of course, and it tells us that here as well. So we know that we're working now, and the problem was fairly simple. It was that Pete's password was incorrect. Now, that's the problem with a lot of these Internet of Things type devices is they're not necessarily the best at reporting their error conditions. So there was nothing on the weather receiver that said that was the problem. Even looking at the HTTP traffic, we saw all green, everything was HTTP 200 OK, everything looked good. It wasn't until we dug into the details of the packet data and looked at that individual response that we figured out that we had a password issue. Now, I would say generally the issue here is shame on the developers of the system for not providing a way in that web application on the weather receiver to actually show that information, to show that the password is now wrong. In this case, the question you might ask is, well, how did the password become wrong? Did Pete re-enter it and re-enter it wrong? And in this case, no. Actually, the system rebooted for some reason. Maybe it was a power outage. Maybe there was a storm the previous night. And when it rebooted, it lost the password information. So it was still trying to make the connection, but the password information had been reset to all zeros or null in its case, and that caused the connection to fail. So a pretty straightforward exercise. It's just a matter of digging in and looking what's going on, but a good example of how we often see issues with these embedded Internet of Things type devices.